All right, welcome back to the deep dive. Today we're getting into the real technical weeds on extreme video transmission. We are looking at a very specific piece of hardware, the DVIGear DVI-2890 AOC. It's an active optical cable. The 90-meter version runs for, what, just under $1,000?
Yeah, around $995. It's a serious investment.
It really is. So our mission today is to understand how these hyperlight cables solve problems that justify that kind of cost.
Well, that investment is really about insurance as much as it is about performance. These are built for what the source material calls mission-critical applications.
Mission critical.
Exactly. Think command centers or maybe large-scale medical imaging, where if the screen goes blank, it's a real problem. They're rated with a mean time between failures and MTBF of over 150,000 hours.
Wait, 150,000 hours. Why is that so important? I mean, doesn't a cheaper cable work fine for a while?
For a while, sure, but it's not about the cable cost. It's about the labor. Imagine ripping out a failed 90-meter cable that's run through walls and ceilings.
The cost would be astronomical.
Right. That reliability rating means you install it once and it just works for decades.
Okay, that makes sense. So let's unpack the performance that demands that kind of reliability. These are fully compliant with DisplayPort 1.4 HBR3.
Mm-hmm. And for anyone who isn't familiar, HBR3 or high bitrate 3 is the standard you absolutely need for this kind of throughput.
And what is that throughput exactly?
I'm pretty fascinated. You're getting up to 8.1 gigabits per second on each lane.
Per lane.
Per lane, yeah. So in total, you're looking at a 32.4 GBPs aggregate. That's what lets you push these, absolutely extreme resolutions.
Like 8K, for instance.
Exactly. You can push a full 8K signal that's 7680 by 4320 at 30 hertz.
And that 30 hertz is perfect for high detail, static stuff like architectural visualization.
Sure. But if you need speed more than raw pixel count, it also handles 4K at 120 hertz.
Which is critical for anything with low latency needs.
Right.
Air traffic control, simulations.
Right. And you're still getting full 24-bit RGB color.
Mm-hmm.
And this is all held stable over the full 100-meter run.
And we should probably mention it's not just a video pipe.
Oh, definitely not. It's also carrying up to 32 channels of uncompressed PCM audio at the same time. It's a full data highway.
So with that much data over that kind of distance, what is this thing actually made of? It can't be just a giant copper rope.
No, it would be impossible to bend, and that's where the active optical design is really the hero of the story.
It's a hybrid cable, right?
It is. It's a mix of 4 glass optical fibers doing the heavy lifting for the video and 6 copper wires for, power and the lower speed data.
And that construction is what makes it immune to interference.
That's the key. It gives it a very, very low RFI EMI profile, so you can run it on a noisy factory floor and the signal stays perfectly clean.
Now, for the people who actually have to install this stuff, the physical design seems like a huge win. It's plenum rated UL CMPOF. That's a big deal for regulations, isn't it?
Oh, it's massive. It means you can run it through air handling spaces in ceilings without violating fire codes. That solves a major headache right there.
And it's also physically easy to work with.
Very. It has a tiny bend radius, but the really clever part is the connectors. It uses these tiny mini DisplayPort connectors on the ends.
So you can pull it through a really narrow conduit.
Exactly. Saves hours of labor. But then you're not stuck with a flimsy mini connector. They include these detachable full-size DisplayPort connectors that have a locking pin. It's just smart design.
And the whole thing draws power right from the source device.
Yep. Ultra low power, less than half a watt. No external power brick to worry about.
So to sort of bring this all together, this technology really just solves that classic distance versus bandwidth trade-off.
It does. It moves the main signal to optics, which is great for distance and integrity, but keeps it completely compatible with all the existing DisplayPort gear out there.
Right.
But, that brings up a final, I think, provocative thought.
Go on.
We focused on the huge one-way blast of video data. But the cable also has to support bidirectional communication over what's called the AUX channel.
For things like EDID handshakes and HDCP, the copy protection.
Precisely. It's a constant low-speed conversation. The source and the display are always checking in with each other to make sure the link is stable and secure.
Constant verification.
Yes. So here's the question to chew on. Over these extremely long distances, what hidden complexity does that constant need for a stable two-way handshake add to the whole system? We're so focused on the high-speed video, but maybe the real challenge is keeping that tiny, essential conversation going.